Hello everyone. Today we are excited to present our project for the course Applications of NLX and LLM. Our project is a conversational AI job search chatbot, which we designed by fine-tuning the Phi3 model with advanced techniques such as LoRA and QLoRA. I am Priya and I am here with my teammates Gautam, Jyoti, Michael and Parth. Let's dive into how we brought this idea to life. We'll start with our project goal, creating a chatbot that personalizes job searches based on specific criteria. Then we'll cover the user prompt feature. Users ask job related questions and the chatbot returns listings that fit their skill sets or location. For data, we were provided a data set, so our focus was on organizing it to help the model respond accurately. We'll also talk about why we chose the Phi3 and the fine tuning techniques we used to optimize it for our project. Lastly, we'll review on how these techniques performed using evaluation metrics to see which gave the best results. This chatbot is all about simplifying the job search. Users can ask for jobs by skills, location, or salary range, and our model, fine tuned on the Phi3 architecture, will filter and deliver relevant job listings instantly. Using LoRA and QLoRA, we made the model efficient and responsive, handling targeted searches without heavy hardware requirements. Imagine searching for data analyst jobs in New York with Python skills. The chatbot quickly narrows down relevant roles, saving users lots of time and effort. Our chatbot was designed to be intuitive and user friendly. Users type in job related criteria like a preferred job title, location, or a skill, and the model responds with targeted listings. This customization makes it a personalized job search assistant, ideal for anyone with specific job requirements, and is a big step towards creating a streamlined conversational search experience. Next, Jyoti will talk about the data sourcing and pre processing steps.
We work with provided dataset containing essential employment information like resume details, job titles, location, salary, job description. And to ensure data quality, we implemented rigorous pre-processing by doing removal of duplicate entries, pattern definition for skill extraction, creation of specialized job query column, advanced data pairing, by generating job description pairs, enhance the model's ability to understand the nuanced relationship between job seekers' queries and relevant positions. At the heart of our system lies the Phi3, a state-of-the-art language model developed by Microsoft Research. Known for its efficiency and adaptability, Phi3 excels in natural language processing tasks, making it ideal for our job matching application. Fine-tuning for precision. We've employed two advanced techniques to optimize Phi3 for our specific use case. LoRA, low-rank adaptation. This method efficiently adapts the pre-trained model by introducing trainable rank decomposition matrices. QLoRA, quantize low-rank adaptation, an extension of LoRA. QLoRA uses quantization to reduce memory usage, allowing us to fine-tune larger models on more accessible hardware. In our case, we've run our model on Labs GPU.
Let's talk about why we're using LoRA and QLoRA for our fine-tuning process. These methods are crucial because they offer memory efficiency, which reduces the computational load on our hardware. They also ensure resource optimization, allowing us to utilize existing resources to their maximum potential. Both techniques are designed with scalability in mind, making it easier to handle larger data sets and models. Lastly, they are parameter efficient, meaning we can fine tune our models with minimal adjustments, leading to faster training times without compromising performance. So in this slide, we outline the fine tuning approach using LoRA. We started by importing the model and setting up an end of token sequence to ensure proper generation limits. Next, we moved to the configuration setup, where we determine parameters like loftq config to fine-tune the model. The build and train stage is where we fit and save the model's weights. And then finally, during the fine-tuning step, We load these weights and evaluate the model using metrics like context relevance and answer faithfulness to ensure the best performance. In this code example, we see how LoRa is configured for fine-tuning. A key parameter here is R equals 8, which controls the rank of adaptation matrices and influences the model's flexibility during training. It's worth noting that while LoRa offers robust performance, it typically takes longer to train compared to QLoRa due to its more detailed matrix operations. Additionally, the loft Q config is set to none, indicating that we're not using quantization in this setup. These settings help us balance memory efficiency with the need for high precision during fine-tuning.
We will now discuss about the QLoRA process. It is basically similar to what the more approach is for LoRa. However, the only change here is when we are building the model, the configuration setup, we have loft Q config here, where we previously set as none for LoRa, but now we will initialize bits as 4, which says there is a quantization involved here. Moving on, we have the code here where we initialized bits as 4, which means the 4-bit quantization to minimize memory. And now we see we are doing double quant, which is further improving the memory usage here. And if you see R is equal to 16 is mentioned here, which is basically the rank. So lower the rank is reducing memory usage, and higher the rank, it uses more memory to learn more and use more weights. So that's where the differentiation is. And moving on to next slide. Yeah, so these are some of the challenges that we faced. One is having GPU memory issues, and second is pairing of job query and description, where extraction of skills and experience from the description, and then later trying different types of instruction prompts for model training. Coming up with what kind of instructions would we could figure out. So that was one of the challenges that we had. Additionally, finding the optimal hyperparameter selection was a significant task, where we try to tweak between R value from LoRa to QLoRa, which has we made from 8 to 16, to see even if it is 4 quantized, if you could increase R, how is the model behaving, and how are the layers being dropped out when we put dropout equal to 0.1. And we tested that out, and we saw there are significant drops in the MLP layers, and that's why we shifted to 0. Now moving on to a next slide, I will give it to Parth.
Okay, so now let's do a comparative analysis between LoRa and QLoRa fine-tuning techniques. So what we have done here is that we have provided with a query, which is what jobs are available for Python developers. So LoRa and QLoRa provide a response, and if you pay attention to LoRa's response, you can see that LoRa gives the specific salary, whereas QLoRa gives a detailed description of the job. And if you compare the scores, evaluation or performance metrics, you can see that the BLEU score is more in LoRa than in QLoRa, and Rogue 1 F1 scores and Rogue L F1 scores, they like LoRa outperforms QLoRa in that, and Meteor scores are identical. Now talking about the evaluation metrics for LoRa. So here, what we have done is that we have given multiple queries and we have calculated various evaluation metrics. If you can see, the Meteor score is the highest, indicating LoRa is good at capturing meaning. The BLEU scores are low, showing there are fewer exact matches, and the Rogue metrics, LoRa's ability to capture relevant phrases makes it effective um, to answer job related questions. Moving on towards evaluation metrics of QLoRa. So what we can see here is a similar trend with high Meteor scores, but then the BLU and Rogue scores are lower than LoRa's, showing that QLoRa has a varied response. But with high Meteor score, it shows that it is still capturing relevant information. Moving on to the final thoughts of this project is that LoRa is more precise, where QLoRa provides a richer detailed responses. And basically the choice really matters between if you want to be, more precise or exact with your matches, or you want more nuanced answers.